Welcome back to Predictapalooza, the 17-inch series. Next up, we're going to be doing Tom's Debutante. It'll be our first Debutante in this series, and the first to feature an 11L43 chassis. The rest have all been 10L43s. Now, I've already redone the main board, restuffed it. Notice it's different in color. It has a green silk screen on it. I think the board material might be a little bit different color too. Slight differences, basically all to do with simplifying things. There are a number of unused pads right in the middle. That, I believe, has to do with the AGC, because this set does not have a local distance switch, which would normally be mounted here on a 10L43. They did that to streamline it for use in a closed circuit type system where the signal is fed in via a coax. Notice the tuner is also different. It's smaller and tilted at a bit of an angle. The tubes stick out this way instead of straight up. I'm sure there are some other differences. It's physically smaller. I don't know about performance-wise. We'll find out soon enough. I have restored one Debutante. In fact, it was also for Tom at the old apartment that was 6 years ago or so. I recall it worked quite well, so we shall see. We already did a power-up when I first started working on this set. We got a raster, so we know the CRT is good, the flyback's good, and all that stuff. That's why I proceeded to just restuff the board. What's left? IF. Do the usual, remove the shield, remove the corrosion, restuff the board. Need to rebuild the power supply. The fusible resistor is a mess, so we're going to be replacing that. And the remaining electrolytics. And I believe, yeah, the linearity control on this one is also shot. The original one, it looks like the wiper's just gone. And I think this was tacked in its place. I think this was sort of piggybacked on that, as I recall when we first got this set. But as you can see, this is trashed inside as well. The wire wound resistive element is kind of broken loose from its support, and it's just, yeah. Might still have continuity, but I'm not going to leave something like that in a set where it's visibly damaged. So we'll be using that same trick, or the redesigned linearity control I featured a while back. Oh, and we'll vacuum it out and such. Now this is interesting. Maybe, at least to me it is. Some years ago, someone, I think it was on Video Karma, well, it was the same TV restorer guy who makes the reproduction cup plates, actually. He is very good with his restorations. He is meticulous. And he encountered a chassis, and he was asking, hey, has anybody seen one of these supports before? What's the story behind them? And I'd never seen one before, and I think a lot of the other posters hadn't either. So we were kind of scratching our heads a little bit, but hey, I have now encountered one as well. So I think that was a feature they added to the 10L43 chassis. It goes here, and it adds some additional support in the area around where the octal tubes are. So this would sit like so. Maybe there was an issue with pulling those tubes in and out, and they wanted to add a little extra something. I'm not sure. There's no screw or any fastener that goes through it. But what it will do is when you're pushing a tube in, it will prevent the board from flexing down. I would have thought that the support over here would be sufficient, but they decided they added it. And so one of the questions he had posed at the time, I recall, is, hey, should there be one over here? And no. I'm pretty sure there is just one that goes there. At least that's what's on this set. So that's what we're going to go with. Alright, so I'm going to flip this around and get to disassembling, and we'll do the usual. Tear all it down, clean everything up, tear out the power supply, and start putting it all back together. Well, this is unexpected. I turned the chassis over to remove the IF shield, and I've never seen a removable plate like this. Every shield I've ever seen in any other model of Predicta was like this. where there were tabs that protruded through slots in the chassis, and then they would twist it over. And to remove it, you straighten them out, pull it straight up, remount it, guide it back through the slots, and twist the tabs over again. But this is all sheet metal screws around to the side too, so that's obviously the shield's held on by this sheet metal screw at this end. I don't know how the rest of it's attached though. To get this plate off and see. That is bizarre. Interesting idea. This is the most reliable part in the set, I would say, so I would think it'd be the least of one's concerns. This area, well, maybe they thought with these openings that was enough to get in there to troubleshoot and fine-tune. And heck, now that I look at it, you know, I need to get another chassis and compare, because I think there were more cutouts on this than there are usually. That is so weird. I think this IF shield, maybe there are tabs with these two screws, that'd be my guess. But this goes back to a theory I posed a while ago. Not a theory, but just an observation that they seem to be working the kinks out of this set as time went on, like a different type of tuner, or changing up the wiring or components a little bit, or upping the wattage on components. But the number one complaint I've heard about this set, well, aside from the picture tubes burning out prematurely, is the difficulty in servicing it. So was this an attempt to alleviate that? I mean, geez, having a removable panel, I mean, heck, you can get at the entire board now. I'm only going to remove it because it makes it easier to work on the power supply, and I want to clean off the corrosion from the shield, but otherwise, yeah, I can get at everything here. And, yeah, I'm curious. So this seems more open than I'm used to seeing. Well, let's just get another chassis and see. Yeah, they did add some openings to it. This rectangular opening and a circle next to it. Solid metal on this. And then obviously the whole IF panel is pretty solid here. What's on the other side of this? Just more circuitry, resistors, capacitors, nothing special, but it's certainly an area that without that cutout is rather impenetrable. So with the addition of that cutout, you can get just about everything. I mean, there'll be some stuff right down in there, in this corner, a little bit up here that you'd still have trouble getting at. But it's certainly an aid. I mean, next step, of course, would be to do the same thing they did on the IF and just cut this out and have it be detachable. It makes me wonder if they had made one more revision to this, would they have done that? It took a little bit of detective work, but eventually I was able to figure out the wiring and circuitry changes for this chassis. In particular, this terminal strip is wired up quite a bit differently from the 10L43. Now if you go back and watch my Filthy Siesta restoration series from 2.5 years ago, or if you watched it and you may recall that I did work out this terminal strip and all the connections on it, and I showed it in one of the segments. Well, I did the same thing again with this terminal strip. I want to draw both of them more neatly and publish it somewhere, because I don't know why, but Philco did not indicate these connections anywhere. They were very good about the rest of it with labeling everything, and everything labeled on here corresponds to the schematic, except for this. It's the B1 terminal strip, and they have the terminals numbered 1 through 10, but they don't label them on here anywhere. Kind of annoying. So I'm going to make up a little decoder that says B1-1, B1-2, B1-3, and shows you what they go to. So this is for the 10L43. There is no service info for the 11L43. There's no published schematic that anyone has ever seen. But at least we can see what components were here. So on the original, they had a big power resistor WR5 and a capacitor C42. With the new version, C42 is gone, and there are 2 power resistors instead of 1. Well, it turns out that things are quite a bit different. And it all seems to be because of the tuner. So whereas the old tuner ran on 260 volts, then there's an AGC, one of the leads is grounded, one is filament supply, and one goes to the IF board. The new tuner needs 2 different B+ voltages. So one of them, they pick it off the 260 volt bus, and that's one of the power resistors. And then that goes off to the tuner. There's also a 275 volt bus that goes through the other power resistor, and that goes off to the tuner and other things, and that's the 140 volt bus, they call it. This takes place of the original resistor they show in the parts locator. And in the old version, or earlier revision of this chassis, that was a 3K 7 watt WR5. So they reduced it to 2.7K, and it's not as high a wattage. Okay? They also rearranged the connections on these, and so it's quite a bit different. For example, on the original or earlier revision, I believe 275 was up here. Now it's down here. 140, I believe, was here. And now we have that dedicated tuner supply. Okay, with that out of the way, I now have some idea better what's going on. My last little puzzle I've encountered is this. 2 wires cut, spliced together, and the insulation is different on them. I think that this is going to the primary of the transformer, and at the other end, it's hard to trace because it goes into this wiring bundle and then off to this control cluster. I think that's just going to the power switch. But why was this spliced like this? That I don't know. I've got an idea. I think I'll find out when I go over this terminal strip. They might have been using one of the terminals here to connect this up. Because at some point you need to have one of these wires goes directly into the power transformer. And then the other goes off to the switch. So at some point you do need to connect 2 wires together. I think they formerly did it either on this terminal strip here or this here, and maybe they no longer had a free lug because they had to use it for something else, and they just spliced them together at the factory. That's a possibility. We shall see. Okay, with that cleared up, I went ahead and vacuumed this out a bit, and I removed the old electrolytic that was down here. Well, now I just need to remove that, and I can rebuild the power supply, and then finally start putting this back together. Here's a little progress update. I removed that last electrolytic and any associated wires that are no longer needed. Installed 2 new rectifiers, 2 new voltage doublers for B+, remove the high voltage box, remove the corrosion with CLR. If corrosion is really bad, I'll use Evaporust, otherwise CLR. Both of them seem to not harm the original labels, but if you do need to get reproductions, or they're missing, or they're damaged, you can get them from the same guy that makes the reproduction couplates, a TV restorer guy. I did trace out the wiring, and this is indeed going to the power switch. This wire goes directly from one side of the AC plug, goes off to the power switch. This is the wire coming back from the power switch, spliced in to one side of the primary on the power transformer, other side of the primary, and the power transformer goes directly to the other side of the AC plug. So this may very well be factory. It seems to be pretty secure, so I'm just going to leave it alone. Flyback. If you've been watching this series, we're up to what, part 14, 15, 16? I really haven't talked much about the flybacks. if you go online to the forums or Facebook group, you may hear all the time people talking about, oh, the flyback looks burned up, it's cracked, it looks terrible, I heard they have a high failure rate. I disagree with all that. I've restored, I've kind of lost track now, over 24 Predictas. All the flybacks have been fine. As far as the cracking goes, they all look like that from the 50s. It's the type of coating they used. It's a type of high temperature or high voltage breakdown wax. Over time, it shrinks, it cracks. With enough heat, it starts to melt and dribble off. None of that is a big deal. If noticeable chunks are missing, not a bad idea to insulate it. I've been using Corona Dope. Thank you for those of you who suggested I store the bottle upside down because I was having trouble with it evaporating. There are, this does have a high VOC content, meaning volatile organic compounds, meaning there's a lot of solvents in here. It's pretty potent stuff. I think they did that because this is meant for service techs, and time is money, and they want this stuff to set up fast. It's kind of like lacquer. Maybe it is a type of lacquer. I don't know. But it goes on like lacquer, meaning it's kind of thick and it dries quickly. And once it dries, it forms a nice tight bond to the wax and to the flyback, and it seals everything and does has a really high breakdown voltage. So just a little light coating of that. Be aware that this will start to dissolve the wax. There's why there's a little bit of discoloration floating around in there. It's because I dipped the brush I was using after going over the wax. I didn't realize it was dissolving the wax, and now I've got a little contamination in there. I don't think it's any big deal, but something to be aware of. All that volatile organics in there does dissolve and attack other stuff. I did this last night. It's completely set up now. Actually, it sets up in that's a half an hour is plenty of time. This one was already in pretty good shape. I think somebody may have already reworked this because it seems to kind of have an extra layer of wax around the high voltage lead. That's on there really solidly. But a chunk had broken off down on the bottom, and there's cracks around, so I brushed it. Oh yeah, there's where there's a chunk missing. When you brush this on, it will flow down into all those cracks and seal everything. It'll hold the remaining wax in place and insulate whatever's left. Am I concerned about sealing in moisture? If it was a really humid day, yeah, I'd be inclined to not do it, or I would try to heat up the flyback maybe with a hair dryer, or wait for a day where the humidity was a lot lower and it was warmer. When I seal it, I'm not doing this, I'm not dunking it, I'm not using a vacuum to draw it into all the pores. I'm basically just trying to seal and stabilize what's left. So it's not completely airtight, it's not going all the way around every void and crack. It's just there to hold everything together and insulate where the coating has fallen off. What's left? Well, oh yeah, we need to replace this. I'm going to do this next, because I need to drill a larger hole here, and I need to drill out the rivets for the one that's still remaining here that's damaged. I want to do that before I put the board on, because it's going to cause vibration, and there's going to be little bits of metal coming off as I drill through this. So let's do that before the rest of it is reassembled. Finally, everything has been reassembled. The vertical linearity control has been rebuilt. I've got it plugged into my Variac. I've got a multimeter set up on the main B+ bus. So let's go for it. No power draw. The switch is probably in the off position. Yes, it is on. All the tube filaments are lit. We have almost 400 volts on B+. Ooh. Well, I did something rather stupid. Just a simple oversight. Wasn't paying enough attention. It's clearly labeled on the board with control. And next to that, B+ 275. Well, what did I do? I took the wire that's carrying the B+, and instead of connecting it to B+, I connected it to the with control, and it roasted. So it's bad. Luckily, I have a few replacements I can get from other chassis. That's not a big deal. But it does mean that it's not functioning right now. So what I did is I went to one extreme, so it's a short right now, which is valid. You should be able to run the control from one extreme to the other. But I don't expect the TV to work quite right with the width control all the way over. But it should power up. We should get a raster. Let's give it a try. Cool. 265 on our B+. We got some noise coming out of the speaker, nothing on the CRT. Maybe. Oh, there we go. Got the brightness up, and life is good. Here's what I'm seeing. Nice, bright raster. And we've got some noise coming out of the speaker. B+ holding steady at 265. The fusible resistor is not smoking or anything. Let's turn the power off. And yeah, it is getting pretty darn hot. So here's what led me astray. Why did I mention about this resistor getting hot? Well, I've been experimenting with coming up with a replacement for the no longer available or made type of fusible resistor they used back then. They do still make fusible resistors, but they're smaller and they look different. And I'm not sure what the original specs were on these. I've never seen it published anywhere. I've tried looking up part numbers and whatnot and haven't really come up with much. I just know that what the resistance is on those, but I'm not sure what the exact current draw is or what the characteristics of it are. So I've been experimenting with some 5-watt, 5.6 ohm fusible resistors, and we'll talk more about that in a dedicated video because it is a topic that comes up all the time. Alright, now we are feeding a signal in. Also replaced bad pilot light in the tuner. Just going with a test pattern for now. Oh, there it is. Tuner is dirty. Let's see. Play around some of these controls here. Looks like our horizontal. Ah, there we go. Hey! Of course, we haven't adjusted the vertical linearity yet, so that would account for that. That's not too bad. Alrighty, we have a screwdriver here. Let's check the linearity. Obviously that circle should be a bit more circular than that. Cool. I'm not going to worry about the horizontal stuff right now because I have the width control all the way at one extreme. But oh, that's not so bad. Let's see, there's a little bit of wavering and twisting at the top, though. I don't like that. That would be from the horizontal hold having some trouble locking in. So that means it's taking a few scan lines for the local horizontal oscillator to sync up with the external incoming horizontal sync pulses, which means it's off a little bit. Now there's a coarse frequency adjust in the back of the set. There's also a coil. I'm going to try tweaking both, see if I can get that better. Here's what I'm talking about. That. This line should go all the way straight at the top. It should not be twisting off to the left like it currently is. Ah, that's better. I did three things. One, I replaced the original dual selenium AFC diode with a dual Schottky modern type, and I tweaked the coarse frequency and the ringing coil, and that got everything nice and stable. We just have one major issue left. Sound. It's basically non-existent. Fine-tuning doesn't help. Now, I checked all these tubes with a basic emission tester. Actually, a Suncor TC162, which is a very sensitive grid emission, leakage test, and shorts test. So none of these are shorts, none of these have leakage, and they all had good emissions. Generally, that's sufficient for a TV. It's not a high-end stereo. Before I dive into troubleshooting, I want to try a different signal source, so I hooked up an over-the-air converter box, and I tweaked the coils a little bit, just kind of went back and forth. This is the best I can get. So there is sound getting through. It's super garbled. And I don't think I've encountered quite this issue before. I'm not entirely sure what the issue might be, but it's a good time to exercise some basic troubleshooting skills. Alright, so where should we start with troubleshooting this situation? Well, I already did some of the easiest things to do. One is to try a different signal source, just to eliminate that as any possibility. I have the same problem with different signal sources, so the problem is with the set, not with the signal I'm feeding into the set. I swapped out the tubes. It's rarely a tube. I already tested the tubes, but I figured that's also something very quick and easy to do, so I swapped out the tubes. The problem is exactly the same. Alright, so let's get out some test equipment. If you have the SAMS photo fact, and it includes this resistance measurement grid, this is a great place to go next. This lists every tube and every tube pin in a grid, and they show a resistance value. Typically it's between that pin and ground. Sometimes it's between that pin and another point like B+. I went through this. All the resistances are fine. That means I didn't make a mistake like putting the wrong resistor value in, or there's no break in a circuit board trace, or a wiring mistake. I also have the luxury of having an unrestored identical 11043 chassis, and I compared my readings and the wiring between the chassis I'm working on and that chassis, and everything looked okay. Alright, so how does the sound actually work? Well, we have a signal coming into the tuner. It goes through that, it goes through the IF, video and sound together, all the way through the detector, and then the video amp. There is a notch filter after the video amp, and that's controlled by this coil here, that picks off 4.5 megahertz. That is the sound carrier. It's FM. After that notch filter, we go into first IF, second IF, and this is the IF transformer. There's a core at the top and the bottom, and then we have a Quadrature Detector, and then we have our audio output. I already tweaked these a little bit by ear, which they actually say to do in the service info. Tune in a weak station and adjust these so you get the best volume and no distortion. I can peak these. That's how I got the garbled audio I have right now. So that all seems to be working right. In other words, as I adjust the primary or the secondary of this IF transformer, the volume increases and decreases. As I adjust the Quadrature Coil, I go from no sound to some garbled sound. That's the best I can get. What's left? Well, there could be a problem with these transformers. Even though they're peaking, there are mica caps, I believe, embedded in the base. Could have silver mica problems, perhaps. I've never encountered it before, but hey, there's a first for everything. Audio output transformer could be an issue. Maybe there's a shorted turn on it. I've used the speaker while testing other sets. The speaker, I'm pretty sure, is fine, so I don't think that's a problem. I can check the voltages. That seems unlikely since we do have plenty of volume. It just sounds horrible. I don't think it's voltages, but I can check that. The fact that the sound varies with the volume control is a good sign, and the contrast affects it somewhat too, which means everything's kind of working right. So it is a bit of a head scratcher, but we can do a few things. One, we can do signal injection. For example, if I take audio, which I believe I can get all the signals I need out of my generator over here. It looks like this is standard audio output. I've never used this before, but I think that is just pure audio out at our various test tones of 300 hertz, 1 kilohertz, 3 kilohertz, 5 kilohertz. I can feed that into the wiper on the volume control through a capacitor to block any DC voltages. I don't want them to feed back and damage my test equipment. If we get clear audio coming through from that, we know our video amp, output transformer, and speaker are fine. We can go back further, but then I'll need to switch to 4.5 megahertz FM, which this generator can also do if I go to this position. And now my output here will be 4.5 megahertz FM modulated with this test tone. I can feed that into various stages of the IF working. In other words, we're going to work our way backwards, going from just pure audio to FM modulated 4.5 megahertz. And hopefully, at some point, we go from clear audio to garbled, and we know the problem lies somewhere in between. Now, one issue I'm going to have if I try injecting a signal while the set's turned on is I've got a signal coming in. So, of course, I'll disconnect my external signal source. But if need to, I may need to break something in the circuit here so I'm not getting a signal out. One easy potential place to do that is this wire here. This white wire goes from the IF, goes from this board to this board. That's how it goes from the IF board to the main board. If I was to disconnect that, there's no signal coming into the set whatsoever. So let's start with the most basic thing. I have a 0.1 microfarad DC blocking cap going to my volume control, and it's going to the audio output on my generator. Just waiting for the set to warm up. Oh, I can hear a tone already. So, instead of going to the center wiper, I went to the outside arm of the volume control, so the volume control does actually work. The reason I did that is I suspected my generator, parent generator, does not have a variable audio output level control, and it does not. You can change the tone, but you can't change the volume level on it. Alright, sounds great. So we know our speaker's fine, output transformer's fine, audio output tube is fine. We're essentially feeding a signal into the grid of the 6BQ5 audio output tube, and it sounds fine. Okay, now we switch to 4.5 meg. Oh, interesting. So with that signal being killed, now we're getting noise coming in. But when this was turned on, noise goes away. So something else I was wondering about is the noise being picked up because something isn't being shielded properly. Well, anyways, let's try going to 4.5 megahertz and injecting that into the circuit. And I gotta figure out where is a good injection point to do that. Now there is a point on the board and in the schematic called the audio test point. And this particular chassis revision, there is a jumper wire going from this point that's normally grounded. I disconnected that, and I'm injecting my signal right at this point. My thought is that it'll go through this coil and go into the grid of the CS6 tube. Let's see what that gets us. I have the volume turned down all the way, turning it up a bit. Again, I'm going through my capacitor blocking, and this time I'm using a 4.5 megahertz IF. I've got the level down very low. Let's go up a bit. Okay. It's garbled, but it's there. I'm going to try tweaking the coils a little bit. We've got this test signal and see if we can make it any clearer. So this is a Quadrature Coil. Which definitely has a profound effect, and it sounds like it should when it's working normally. There's obviously a lot of noise coming in. And let's see, if I'm going in to this point here, hey, I'm past that 2-core IF transformer. I'm going in right here. So this Quadrature Coil, and there isn't much to it. It's kind of noisy. Now I would like to completely disconnect this from the rest of the set to eliminate external source of noise. I think I could just pull this tube. Let's try that. Changed, that's for sure. But it's still distorted. Well, that sounds right. The volume's a lot lower, but it sounds right. There is a procedure for doing this using a VTVM and such, and I will go through and do that. Just trying to pinpoint the problem. It sounds good, but at the 300 hertz range, it sounds like there's almost a tremolo effect going on to it a little bit. It's kind of odd. But generally, it's a pretty clear tone. I mean, it's certainly a lot better than it was sounding earlier. Okay. So, what does that tell us? Well, the problem may be further back. So let's try putting that tube back in and inject this signal further back. Turn my level down, because now every time you go back a stage, there's more amplification, so you want to use a little smaller input signal. Alright, well, again, it's getting through, but boy, it sounds like crap. Now, because I've gone back further, now I can adjust this coil as well. I'm not sure about it, if it's the top or the bottom slug. Neither one seems to have a huge impact on it. I'm not sure how sharp of a filter that is. And as before, the IF transformer does respond. I can peek it. I'm going to the Quadrature Coil again. And it's just horrible. Alright, well, they do give resistance readings for the transformers, so I'm going to go through, I'm going to check that. I'm going to go back further, and so we know we're good here. The problem lies somewhere in here. So I'm going to go over everything again. Well, the good thing is I do have spares of all these transformers if I need to swap one out. Because I haven't checked the resistance on any of them yet. It is possible that we could have an open winding, but enough of a signal is still leaking through. It's just getting very distorted, so that's a possibility. That's a simple enough thing to check. They're all very low resistances. 3.5 ohms, 4 ohms, 3.4 ohms. I'm reading the value next to these little transformers here. So I'll go through that. I checked the windings in each of these transformers. They all check out good. Now, it is still possible for there to be a short in a winding near maybe one of the ends, so it doesn't change the resistance value that much, but it could affect the performance. Maybe that's an issue. There are some capacitors embedded in some of these coils. I believe in this one in particular. I've never dissected one of these, but it is possible that there could be some silver mica disease going on. So that's a possibility. There are some ceramic disc capacitors. I've never needed to replace them in the past. They're very reliable components, but it's not impossible that one of them could be leaky or gone way off value. Now you might be thinking, hey, I damaged the width control, shorted it out, maybe that damaged something else. Nah, not really. That wiring error was just completely separate, isolated from the audio circuitry, so I really don't think so. Well, how can we narrow this down? Well, we're going to inject a signal right at this point. That is the signal coming from the IF board. That is composite video, sync, and 4.5 megahertz FM modulated sound. So we're going to inject our 4.5 megahertz modulated signal from our test pattern generator right at that point. And then we are going to get a scope out, and we're going to check the input. In other words, the output of our generator. Make sure it's clean. And then we're going to go through every single stage, every point, and see where it starts to get distorted. Hopefully, we will find an obvious place where, hey, it looks good here, it looks bad here, the problem has to be in between, and whatever components lie in between, that's what we're going to check. I also did dig up a replacement width control. It's 15K 2 watt. I scavenged this from a parts chassis. We will be installing that as well. I finished replacing the width control, and I'm setting the chassis up so that I can work on it in a vertical orientation so I can get at both sides of things. Before I power it up, I want to do a little work on the tuner. I checked both tubes. They are originals, and they are both still good, so I left them in. Then I want to clean this. I was having a lot of trouble when I flip between channels to get them to lock in. Now this is normally covered by a shield, but I didn't want to just shoot contact cleaner down in there. Yeah, there are some holes, and maybe that's why those are there, but I couldn't see well enough, so I took it off. What I don't want to do is just flood this whole thing with contact cleaner. I want to get it on the actual switch surfaces down in there. I may use a little toothpick, Q-tip to get it down in there, just on those surfaces. Almost looks like they're gold plated, or some kind of silver gold alloy. I'm not sure what that is. It doesn't look like pure silver, not corroded, that I can see. I wonder, well, it could just be, again, smokers. You know, residue builds up on these, but they don't look oxidized. But either way, deoxide should take care of that, and while I've got it all apart, I can also lube it up. There is a little ball bearing for the channel detent clunker as it goes around. Alright, so I will get that done, and then pop the cover back on, plug it back in, and then I want to power it up just to make sure everything works as it did before, assuming the problem is still there. I don't see really why it wouldn't be, and we're going to resume troubleshooting. I have some good news and some bad news. Good news is, cleaning the tuner made all the difference in the world. Bam. No monkeying around, twiddling with the knobs, trying to get it to lock in. The width control does work. Now, we also have great sound.
These other brands are just way too flimsy and leave way too much.
So what's the bad? I don't know why it didn't work before.
There's no comparison, and it's custom designed 10%.
Now I imagine some of you were curious to see what those waveforms would have looked like as I went through the various stages, so I'm still going to set that up. I think it will be educational both for you and myself, because I haven't done it before on one of these chassis. So I will get out a scope and hook things up, and let's start poking around. Let's talk test equipment first. I'm using a Sencor VG91 universal video generator on the 4.5 megahertz FM mode. Scopes. I had my choice of my old HP digital or a couple old Tektronix analog. I went with the analog scopes, the 465 in this case. Both my analog scopes need serious overhauling. I bought them used. They have not been refurbished. They have not been calibrated. But they do display analog waveforms in more detail, so that's what I went with. Some of the ranges on the volts per division do not work properly. However, if I can get some of them to work right, and if I use the variable gain control, we can get a pretty good looking waveform. Now this was surprising to me. I thought we'd have a nice pure 4.5 megahertz sine wave coming out of this. We don't. Right now I have no modulation, so it should just be a pure 4.5, but there's junk in there. There's a high frequency riding on top of it. I'm guessing that's leakage coming through. I'm not sure. What's surprising to me a little bit is if I went to some of the others, there are other fixed frequencies for doing various alignment functions for the video trap, sound trap, and so on. Those do look pretty darn nice. That's the range of the scope. It's a 100 megahertz scope. I'm looking at almost a 50 megahertz signal. But we can see the detail. Anyways, it's 4.5. It looks a little... I think what's happening is some of these 45 megahertz signals are leaking into the 4.5. However, there is a notch filter on the Predicta, which should take all that out, and we should get a nice sine wave out of it. Let's change time base a little bit. Now, if I engage the FM modulation, I can pick 300 hertz, 1 kilohertz, 3 kilohertz, 5 kilohertz. Then it starts to waver a bit. It's a little hard to see, but it gets kind of fuzzy looking. That is the FM modulation. So, we're going to take that and we're going to inject it at the wire that connects the IF board to the video board. And we're going to go through the stages. What I expect to see is this will go from looking like this to being a nice 4.5 megahertz sine wave, and we're going to have to cut the level way down because the TV is going to be amplifying it. We're going to see it get larger with each stage. Then when we get to the Quadrature Detector, it should go from a 4.5 megahertz carrier to sing the modulating audio. So if I have it off, we shouldn't see anything, just DC. If I go to 300, we should see the 300 megahertz, or sorry, the 300 hertz audio, nice clean sine wave being transformed out of this. Alright, let's hook it up, see what happens. Here's my setup. Output of the VG91 is going through coax that ends with 2 alligator clips. The ground clip is going to the chassis. The hot side is going through a 0.1 microfarad plastic film cap. It's a 1000 volt cap, but you don't need one anywhere near that high in value. The other end is clipping into where that wire comes out of the IF board. I didn't bother disconnecting it. It seems to work alright if I leave it hooked up. My scope is hooked to pin 2 of the 6U8, or in some sets it's a 6EA8. They're equivalent tubes. I'll show you that on the schematic. So there is the video output tube. Plate circuit goes through a transformer. On that left side of the transformer, that is the 4.5 megahertz parallel resonant tank that picks off that signal, which goes over to pin 2 on that 6U8, the SIF tube, sound IF tube. That's the grid of the tube. And what does it look like on the scope? Hey, it's a nice, pretty, clean sine wave at 4.5 megahertz, and that is with no modulation. If I turn it on, you hear it out of the speaker. And see, the waveform gets a little bit fuzzy. That's from the FM modulation. Now I'm going to leave it like this, and I'm going to grab my alignment tool. I'll also grab a tripod, and you guys can watch that while I tweak the core of that notch filter transformer. No, it's not your imagination. I have been referring to the same part by different terms because I see it referred to it in different ways on different schematics. The sound pickoff coil, a notch filter, a trap. It's an inductor and a capacitor in parallel. They have a resonant frequency. Whatever that frequency is, that will pass through with the least amount of attenuation. We want that to be 4.5 megahertz. So I'm going to take a little plastic hex alignment tool here and feed it down to the top of that transformer, because I think it's the bottom slug. I'll know in a second here. Yes. And it was off. Not by much. So that's all we have to do, is go back and forth and rock the little core back and forth until we have the peak amplitude. Which is right about there. Yeah, you can do it by ear, which is what I had done. But see, I was off a little bit. In the real world, will you notice it? Not much, but hey, since we can, we might as well get it right. Now I'm going to decrease the amplitude on this, and let's go forward a stage and see what we get. Alright, now all I did was move my scope probe over to pin 1 on the 6CS6 sound discriminator tube. That means it's been amplified by the 6U8, and it's gone through this IF transformer. It has a tunable primary and a secondary, and we're looking at the grid of the next tube. In other words, we've gone through one stage of amplification, which is why the sine wave is now larger, and it's going off my grid there. So I'm going to cut down the input level, and I'm going to tweak the IF transformer. There's 2 slugs at the top and the bottom. I want to peak them both. Again, I did this by ear before, so I expect it should be close, but I don't know. Oh, I was off. I was off by quite a bit. Oh, my flaky scope. I'm not doing anything. There are dirty contacts on the attenuator in my scope. In some of the ranges. Kind of has a mind of its own at times. Anyways, here we go. So I was off on this too a bit. Now I'll do the other core. Ooh, that one was also off. Oh, that one was way off. So now we should have a much louder sound. Just changing the level on my generator. You want the level to be large enough that you can get a clear waveform on your scope, but you don't want it to be so large that you're overdriving the amplifiers. So I'm actually now on the lowest. There's a low, medium, and high attenuator. I'm now on the lowest range with the level turned down almost all the way. This is the lowest output level I can get from my generator. Alright, so the next stage is the Quadrature Detector. So there's a few different ways to turn FM into audio. I'll do a video on that someday. Most of the sets you've ever seen me restore on this channel use a ratio detector. This uses quadrature. Now the 21-inch sets have a tube, I think it's a 3BN6 or something like that. It's a tube specifically designed to be a quadrature sound detection tube. This uses a 6CS6, which is can be used for a number of things. It's kind of a general purpose tube, but they rigged it up in such a way that it forms a quadrature detector. How does that work? They do a phase inversion, so they feed the signal into two grids 90 degrees out of phase with each other, and that combined with a coil magically transforms this into audio. Now, I have no modulation on it. I'm going to turn it on. I'm going to move the scope probe over to, well, let's go to the plate on that same tube. Choose pin 5. 2, 3, 4, 5. There's not much to hook on to. Hang on. I should probably change this to AC coupling because there's a little positive voltage on that plate. Unfortunately, there's nothing stable for me to hook my scope probe onto, so I just have to hold it. And let's increase the level a bit. Maybe the plate isn't the best place. Let me hunt around and see if I can find a better place for audio. Well, let's try the grid of the audio output tube. That's this. The grid on that 6BQ5 was also hard to get at, so I decided to go to one arm of the volume control, the one on the left side there, that goes through that .003 and a resistor, and then goes to the plate on the 6CS6. And how about that? We have a nice, clean, 300 hertz sine wave. We go to 1 kilohertz on the generator. Let's see, higher frequency sine wave, 3 kilohertz, 5 kilohertz. And no modulation is DC, as I mentioned earlier. So that is all working wonderfully and looks great. Now a little bit of wiggle. The volume control is right next to the power switch. I think I'm picking up a little bit of 60 hertz coming through there. But otherwise, yeah, everything is working splendidly. Now this is also kind of interesting. See what I'm doing here. Show you what I'm adjusting. This is a variable output level. As I change that, hey, the sound volume is staying the same. That is the beauty of frequency modulation. I'm basically simulating the received signal strength varying. Imagine you're using an over-the-air antenna and you got a storm going by, or varying atmospheric conditions and whatnot, or maybe it's a weak station. If you were using AM for sound, the volume would be fading in and out. Your AVC, or automatic volume control circuit, will be trying to compensate for it. But FM is immune to varying input signal strengths, because it doesn't care about the amplitude of that 4.5 megahertz signal. It cares about the spacing between the zero crossing. In other words, the change in frequency, not the change in amplitude. So, I hope that all makes sense. If you want to align the sound and you've got a generator and you've got a scope, you can inject it right at the input on that main board and then go through those various points I showed you. Basically the grid of the 6U8 and the grid of the 6CS6. There is one more coil to adjust. We can do that right now, the Quadrature Coil. And that is just a single inductor. There's just one coil of wire inside that. So with a ratio detector, you would do, you check for the zero crossing point and symmetry and stuff. But this, you kind of adjust so it's loud and it sounds good. So that's distorted, it's not symmetrical. We want it to go for largest amplitude that's symmetrical, which I would say is right about there. Cool, now let's hook up back with our over-the-air broadcast and see how beautiful the sound is now.
I used to wake up a couple times a night, and now
That is some excellent sound.
And wake up refreshed.
Finally, something that works. Thanks, QNall.
Very clear. And no buzz. Often when you have commercials on the screen and you've got that harsh white lettering on a black background, you can get buzz. And no.
Arby's hush puppy breaded fish strips, and you're transported to a classic southern fish fry.
Got the contrast up all the way.
Fries and you're back at Arby's. Arby's.
So now it's down to my usual practice of a couple hours of burn-in testing up on the bench. While I leave the set playing, I will finish cleaning up the cabinet and put it all back together and call this one done.
That's why a Cigna Medicare plan gives you care that fits your health needs and budget.